We've got opposite signs here on the y's. That's good, but our coefficients don't wipe out. They're not both 5s and they're not both 3s. Here we've got our coefficients are perfect, but they're both positive. So I've got to do something fancy here to one of the equations. I think I'll work with the 2's, the x term, because that coefficient is all fine. I'm going to take one of the equations and multiply it times a -1. That way it'll change the sign on all of these pieces. If I go -2x, -3y, -12. And then I'm just going to copy this. 2x minus 5y is equal to 44. Now I can eliminate this term because the coefficients are the same and this one is a positive and that one is a negative. So this term can be eliminated. Now I've got to combine the other terms. Two negatives, I'm going to ADD the numbers, add the numbers and get an 8, but it stays with a negative value for y. And then to subtract these two, this is a positive and that's a negative, so I actually have a subtraction problem here. 2 and 3, 32. And the positive is larger, so it's a positive 32. Let's solve for y. Divided by a -8 on each side. Y is equal to a -4. That's my first value in my ordered pair, but that's my y term. So I'm going to go -4. This value can be placed back into any of the equations, the original, the one that I multiplied by a -1, or the second one. I'll use the second one. 2x minus 5y is equal to 44. The value for my y fits here. So it would be 2x minus 5 times the quantity 4, because that's our -4, that's what I'm substituting, equals 44. 2x. Distribute. A negative times a negative is a positive. 5 times 4 is 20. Equals 44. Here's the wall. Minus 20. 2x is equal to 4 and 2. 24. And it's a positive because that's the larger number. That's the larger numeral. Divide by 2 on both sides. And x is equal to 12. That's the other part to the ordered pair.